So we say, apparently there are levels of measurement, right? So remember, measurement, we are assigning what? Numbers or quantity to things that are normally abstract, yeah? And this based on a set of rules, right? And we're saying, of course, there are various levels of measurement, meaning there are different approaches that we can take to measuring things. Yeah, so we want to look into details about these levels of measurement, and hopefully this will be the time where something is pressing something. I hope it's not a headphone that's causing it. To watch this short video, and whilst you watch it, I want you to look out for certain keywords, right? So you're looking at the nominal, the ordinal, and then interval and ratio. I think the last two words are words that we mostly use in everyday English, so we can actually at least relate to them in a lot easier way.
Imagine that you are a psychologist and you want to do a study to see whether eating breakfast will help kids focus. You think that the students who eat a healthy breakfast will do best on a math quiz. Students who eat an unhealthy breakfast will perform in the middle, and students who do not eat anything for breakfast will do the worst on a math quiz. So, how do you do your study? Where do you even begin? In research, one of the first things that you have to do is identify your variables, or factors that can change. For example, whether a person eats breakfast or not is a variable. It varies from person to person and perhaps from day to day. A person can eat a healthy breakfast, eat an unhealthy breakfast, or not eat breakfast at all. If eating breakfast did not vary, every single person would eat the exact same thing for breakfast every single morning. Likewise, performance on a math test is a variable because it varies from person to person. Susie might do great on a math quiz while Jonas fails it. Or Susie might do well today, but not as well tomorrow. Whatever the reason, scores on a math quiz change, and therefore they are variables. So we know that our variables are eating breakfast and math performance, but how do we measure them? There are 4 major scales or types of measurement variables: nominal, ordinal, interval, and ratio. The scale of measurement depends on the variable itself. Let's look closer at each of the 4 scales and what types of variables fall into each category. You might have noticed a difference in our 2 variables. While scores on a math test...
By the way, afterwards, I will ask you what they mean.
Yeah, sure.
So I'm pausing here. Sorry.
are reported as numbers, eating breakfast isn't numeric. A person eats a healthy breakfast, an unhealthy breakfast, or no breakfast at all. These are not numbers, but categories. A nominal scale of measurement deals with variables that are non-numeric or where the numbers have no value. In other words, we can put them in any order and it wouldn't matter. Think about the numbers on the jerseys of football players. Is the player wearing number 1 a better player than the player wearing number 82? Maybe, but that doesn't have anything to do with the numbers they wear. Jersey numbers have no value as far as telling us anything about the ability of the players. It's just a way to identify them. Other examples of variables measured on a nominal scale include gender, race, and the number on pool balls. Sometimes, for statistical analysis, a researcher will give non-numeric variables numeric values. For example, we might say that students who eat a healthy breakfast are -1, the students who eat an unhealthy breakfast are 0, and the students who do not eat breakfast are +1. These numbers are just a way to mark who is in which group, but don't really have value. Let's say that instead of looking at grades on a specific math quiz, we want to look at the letter grades overall for the course for each student. So Susie has an A and Jonas has a D, and there are other students with B's and C's and F's. In this case, the letters are not completely meaningless. Unlike football player jerseys, for example, we know that Susie is doing better than Jonas, but how much better? An ordinal scale of measurement looks at variables where the order matters, but the differences do not matter. When you think of ordinal, think of the word order. In the case of letter grades, we don't really know how much better an A is than a D. We know that A is better than B, which is better than C, and so on. But is A 4 times better than D? Is it 2 times better? In this case, the order is important, but not the differences. Have you ever filled out one of those customer service surveys that companies send out? They might ask a question like, "How was your experience today?" and ask you to rate it on a scale of 1 to 10. Those too are ordinal. Other examples of variables measured on an ordinal scale include difficulty, hard, medium, easy, and the order of finishing a race, first place, second place, and so on. Okay, but what if we want to measure something where the differences between the numbers do matter? For example, what if we decide that the temperature of a person's breakfast matters? We believe that the kid who eats the hottest breakfast will do best on the math test, and the kid who eats the coldest breakfast will do the worst. When the order and differences between the levels of a variable matter, but they are not in a ratio, it is measured on an interval scale. Intervals are the distance between two things, so you can remember this because we are looking at the distance between levels of a variable. Temperature is a good example of a variable measured on an interval scale. If one kid eats a breakfast that is 100 degrees and another eats one that is 50 degrees, the difference between those two breakfasts is 50 degrees. That tells us something about how far apart they are. Likewise, if it was 70 degrees last month and it is 35 degrees today, we know how many degrees warmer it is. But note that we wouldn't say it's half as warm today as it was last month. That doesn't make sense. That is why, while the differences are meaningful, the ratios are not. But what if the ratios are meaningful as well as the differences? Let's go back to our original idea. We want to look at the nominal variable of eating breakfast, and we also want to look at the scores of the students on a math quiz. If Susie gets a 90 on the test and Jonas gets a 45, we know that Susie did twice as well as Jonas. The scores, which are percentages, are ratios. That is, the numbers tell us how much of one thing we have in comparison to another thing. Variables measured on a ratio scale are numbers where the order, differences, and ratios are all meaningful. Think about it like this. If you can say that's twice as much about one number in relation to another, then it can be measured on a ratio scale. Things like number of minutes in a commute, weight, or height are all ratios. Susie can spend twice as long commuting, be half the weight, or twice the height of Jonas. In psychological measurement and research design, there are 4 major scales of measurement used to talk about variables. A nominal scale includes variables where the order of the units does not matter. Ordinal scales consist of variables where the order matters, but the difference between the units does not matter. An interval scale looks at variables where both the order and difference is meaningful, but the ratio of the units is not meaningful. Finally, a ratio scale is made up of variables where the order, difference, and ratio all matter.
Talking about, the video we watched, and we were talking about the terminologies really. So we were looking at what nominal scale is, ordinal scale, interval, and then the ratio. I think the key thing is that as we go higher, the previous ones become sort of a subset of the other ones. And we were just having discussions about examples and other things. Yeah. So measure of identity category, basically mostly important for quantifying things, giving numbers to these sort of things. In terms of the number does not necessarily show the value of what is being measured. Okay, so basically it provides no information regarding the ones that are higher up. That is why this is levels. That's why it's called levels, because some absorb the others. I think what I would say from the previous one is just mostly used for identification, the nominal. Yeah, just to identify things. Okay, and then the ordinal, the order actually matters. So things like, of course, fantastic, good, okay. You can tell that there is some form of order in there in terms of placement. Whether you're feeling bad, if this is got more yearning towards the negative feeling or more towards a positive feeling. So you've got bad, good, excellent, fantastic, brilliant, amazing, wonderful. So basically it's used for ordering things, basically arranging them in a series manner or to provide information regarding magnitude or size and other things. Okay, so we made mention of the Likert scale earlier on, so we just carry on from there. Interval, we have talked about the difference matters. So if you've got something like different places, and you can make use of temperature or something like that, the difference in between them matters. So you think about which one is hotter than the other, and that gives you a perception of it. So cannot establish how many folds. If they really cannot establish by what amount, you know what I mean? This one is this much larger. It's just giving you a difference between them. Yeah. So it's not necessarily A relative to B. It's talking about, difference between the two of them, inference. So anyway, you've got a bit more information about the differences, but in here, we're talking about ratios. And normally when people have, let's say, a variable X relating to variable Y, that's where you are looking more like performing things such as this. So we get things like how or hold of it and other thing. Yeah. These ones absorb whatever is the previous and add more to it. Yeah. So if you look at the nominal, it's just basically you are adding labels to things. Basically, just saying this represents 1. This represents 2, that represents 10. It's just more about representation of things with numbers. Then if you look at the ordinal, first of all, you have to assign numbers to them. Then the order also matters, right? So you're just doing some form of ranking. Okay. Then after doing the ranking, you're also saying that, of course, this one is bigger than the other by this much in terms of the differences between them. Then you are going towards the interval. And then if you are looking at how in terms of ratio, 1/10 of something or twice as much, you know, those